I first saw a hummingbird dry itself off, when I first observed that jellyfish cloning itself, when I saw the first heartbeats of the chicken embryo, it was like my mind cracked open. Those experiences humble you when you see something you don't fully understand. They rewire your brain and teach you to see the world with fresh eyes. As a science photographer at National Geographic is driven by a simple question. What can we learn by observing the natural world? Today I'm going to share 3 stories that illustrate how I approach that question. For my project on hummingbirds, I photographed how scientists study their biomechanics. For example, this is hummingbirds hovering under a miniature fog machine that allows you to visualize the airflow around its wings. Scientists use artificial flowers to study the structure of their tongues. And they use high-speed cameras to watch how they dry themselves off. They shake themselves so quickly that the water flings off of their feathers. I was able to capture these movements with a special high-speed camera that slows down their motion 100 times compared to what your naked eye can see. Take a look. Thank you. At first glance, jellyfish may not seem nearly as impressive as hummingbirds. But if you take the time to understand their lives, you will discover they have their own special secrets. To prove it, I developed new filming techniques to bring you into their world, including a camera system that could send a lens through the front of an aquarium. So let me show you the secret life of a jellyfish. They start their lives as little polyps, just a few millimeters across, just the size of a sesame seed, attached to the bottom of the ocean. And they stay there, feeding and growing, catching plankton drifting by, waiting for the right signals in their environment to tell them that it's safe to transform. When they sense that the time is right, they undergo a radical transformation. In a process called strobylation, they elongate their body and they pinch it into a series of discs. Each of those discs grows a separate set of arms and becomes a separate individual jellyfish. The single polyp clones itself. And when they're ready, each of those little baby jellyfish breaks free one by one to start their life out in the open ocean. And after this process is complete, that polyp regenerates itself. It regrows those tentacles. And it repeats this process year after year. No one knows if that process has a limit and whether or not they're resetting their biological clock with each cycle. Now, compared to a hummingbird and a jellyfish, you might think a chicken egg is not so exotic. Perhaps it's even a little bit boring. There's nothing particularly unique about its powers. There's nothing really special that it can do. But maybe that's the point, that all life has a bit of magic if you know how to look. Here's what I mean. If we zoom in on this egg and we light it from behind, you will see a hidden constellation of details. This is caused by the uneven deposition of calcium. Now, once we fly through this shell, you'll start with a fairly familiar landscape. The egg white and the egg yolk that we all know. But if that egg has been fertilized and incubated, this little clump of cells called the blastodisc starts to grow. It expands across the surface of the yolk. And when you speed up time, this process called epiboly looks like waves crashing on an alien ocean. By the end of the second day of incubation, you can see a structure that scientists call the blood island. This is the circulatory system of that developing embryo, starting to develop in order to transport nutrients from the yolk back to its body. This is now real-time video showing you the blood cells pumping through this circulatory system with each heartbeat of the embryo. By the fourth day, you can see the segments of its backbone. You can see the developing limb buds. You can even see this little balloon-like structure that's called the allantois, where it's going to store its waste inside the egg. By day 6, you can see its limbs are more fully developed. Its heart is still clearly beating. By day 10, its eyelids are visible, its toes have clearly formed. By day 12, you can see the beginnings of its feathers. By day 19, it has filled the entire volume of the egg. It's beginning to open its eyes. By day 20, it has to reorient its position inside the shell. And then it has to break through the shell membrane, just like that. That was it taking its first breath of air inside the shell. Day 21 is when it can finally break free. Those first few hours are an exhausting time for this chick. It's still wet, it's tired, but by the end of the first day, it has dried out and started its life as a chick. So scientists study hummingbirds in order to design better flying machines. They study jellyfish to better understand the processes of aging. They use chicken embryos to study heart defects and even cancer. The biomedical and engineering applications are potentially groundbreaking. But those applications are not what draw me to science. When I first saw a hummingbird dry itself off, when I first observed that jellyfish cloning itself, when I saw the first heartbeats of the chicken embryo, it was like my mind cracked open. Those experiences humble you when you see something you don't fully understand. They rewire your brain and teach you to see the world with fresh eyes. I got addicted to that feeling, and I wanted to become a student of wonder, so I created Wonder Lab in Berkeley, California. Wonder Lab is part photography studio, part research lab, and part classroom. And one of the discoveries we made this past year is that macro photography can be an incredibly powerful tool to give students the experience of wonder through science. So this past year, we sent camera kits that we designed to classrooms ranging from age 3 to 18. And what you see here is a 6-year-old using our prototype kit to investigate freshwater biodiversity. And what we saw were students who were previously disengaged or distracted actually started asking to stay after school to continue using our camera kit. Unlike a microscope, the camera gives the students the freedom to play and experiment. It creates a sense of connection by facilitating a shared experience of wonder. Now, watching these kids play with these kits, it made me reflect on how our early experiences shape us. It's something I'm thinking about a lot recently as I watch my 1-year-old daughter, Maya, grow up and start to explore. We all start out so open to the world. And as we grow, our perspectives narrow and they become more rigid. Amidst all the distractions, we lose sight of what we really care about. I first picked up a camera to hold on to that power of focused observation that we're all born with. I believe our attention is sacred because what we pay attention to matters. It determines what we ultimately care about. And yet we lose grasp over our own attention with each passing year. To me, the antidote to scattered attention is wonder. Wonder cuts through the noise. It stops us in our tracks. It expands our notion of what is possible, and it reminds us that we are part of something bigger than ourselves. Imagine if we could all tap into this superpower to slow down and look more deeply at the world around us. This is the lesson that photography has taught me. This is what I hope to share through Wonder Lab, because I don't see how we can tackle the challenges of tomorrow without harnessing our greatest power, the power of wonder.